So this is our discipline-specific presentations. We have 3 faculty who are going to talk about how they use LibreTexts in their discipline. If he has any questions, we can move on to Karsten, who's doing our last presentation. I see you're here somewhere, Karsten. There you are.
Yes, I'm here. You can hear me too.
I can.
Great. So this summer, I sat down and said, I want to make myself a textbook for a course that's called Chemistry of the Life Sciences. It's taken by nursing students. It's a single semester course. There was already some textbooks on LibreTexts for those types of courses, but I wanted to use a course sequence that starts with a little bit of bonding and then goes right to organic chemistry, preparing students for using organic molecules as examples then for aqueous chemistry and then moving on to biochemistry. So that it wasn't available, and I decided I would remix a textbook like that. Before I talk about this, I wanted to ask you if there's any textbook that you would love to have as an open textbook, but you just haven't found an appropriate one. So in the chat, if you could just, if you're not doing chemistry, that's fine. But a course that you're teaching where you would love to have an open textbook and you don't have an appropriate one available at the moment.
I see Intro Chem and OChem.
And I guess the other question I have for everybody, and this is also to see if you're still awake, can you give me a thumbs up or a thumbs down if you have either already used an open textbook or if this would be new for you using an open textbook? And you can either turn on your monitors or you can put up a thumb or you can say something. Okay, and I guess new means this is brand new for you, this idea of having an open textbook. Okay, I can tell you about myself. I've used OpenStax Chemistry. That's for the general chemistry course. I think they on purpose decided to have a very boring textbook that is exactly the same as all the other commercial chemical general chemistry textbooks, so that it's easy to exchange. I think that's a good strategy. But in the case of the 1 semester general organic and biochemistry, the textbook I wanted and already had commercially available had a non-standard kind of order of things, and so it was difficult to find. So I'm going to just jump right in and show you the textbook. When I talk about this, I never know if I should say I wrote this or I mixed this or is it my textbook? So this is very complicated for me. And I try to sort of annotate where different parts were coming from, as you will see in a second. And actually, I want to do one thing and just put that link in the chat. So if you want to refer back to it or want to browse as I'm talking, you can do that. So here it is. And again, it's not quite clear what my name does in front of it because the contents of most of the chapters are not mine, they're just remixed. So I already mentioned this, the order is attractive to me. So there's just a quarter of the semester on basic atoms and bonding, and then it jumps right into organic chemistry. So it becomes relevant. The molecules are the relevant ones. And then it jumps back to aqueous chemistry, but then I can talk about something like acetic acid, and people already know what the functional groups are. And then it goes on to biochemistry. And it's a bit of a wild ride to do all of this in a single semester. So it's nice not to sort of do 3/4 of the semester copied from general chemistry and then squeeze in a little bit of organic and biochemistry, but that's really puts that front and center. So right now we're doing aqueous chemistry. I learned there's a table of contents here. So I don't think that was there when I mixed the textbook, but then it suddenly appeared. So aqueous chemistry has a chapter, solutions, from Ball's textbook, and acids and bases. So this is basically all from the same textbook, which is an intro chemistry textbook. But organic chemistry is taking from a lot of different textbooks. One is an intro textbook, one is a biochemistry textbook, so it mixes things up a bit. Okay. One thing I want to briefly show is I have sample exam questions and I have slides in here too. So when I give students lecture videos at the moment in the pandemic, they have access to these slides. And I'll talk a bit more about this at the end of my little presentation here. But one of the things I did during the summer is exchange those figures into open source figures. Okay, but the first larger topic I want to talk about is the lab. So I've been teaching a lab from a lab manual that I wrote myself, and I decided I want to have it publicly available. So I have these as two versions. The lab I've been teaching for the last 10 years. It's actually a chemistry lab. And so here's an example: oxygen and air. You enclose a sample of air and you put some steel wool in there, and you see how the volume changes over time when the oxygen gets used up, and that tells you how much oxygen there is in air. And then I have a new set of write-ups for a dorm or kitchen activity. So I don't call it a lab. I don't want to be too presumptuous. And we just did this one, so I'll just pull that up. And this illustrates nicely how flexible LibreTexts is. So I put this together before we started, but then when the first group does their lab and I see that there's some things that they get stuck with, I put another picture in there, or I put a little video in there. So it's a mixture of text, and there's one step that's kind of complicated, where you have to put this test tube upside down and get some air out. So I have a little video about that. Then there's the procedure here. What I also should show is that students do this with a little lab kit that they got from me. So I guess that's in the beginning of the lab activities. There we go. So this is just a little bag with stuff. They picked that up at the beginning of the semester, and now they have it in their dorm or at home. And you can sort of see what's in there. One of the most versatile things was this little bit of Play-Doh. So we made molecular models with that, but then we also used it as a little test tube holder because it turned out they had to have their hands free. And there's some pH strips in there, and the steel wool, and some not so good volumetrics, so we can measure volumes. Okay. So I've been intensely using this material because they need to read it when they are doing the lab. The textbook I haven't integrated as much as I wanted to, and if I do, I will also probably see that I want to revise some of the stuff, because right now the parts don't necessarily fit perfectly together. So maybe it needs some glue to do that. I want to take a little break and ask you if there's any questions at this point.
How are the kitchen labs coming along? I want to implement this for next quarter's general chemistry class. And this seemed to be the only real way of making a quote unquote lab that doesn't involve nasty chemicals that are shipped out to people.
So I thought they might be a little bit too boring, but what happens is because, well, let me tell you the model I have in the lab. In the lab, I have groups of 3. And one of the students has to write up the lab, and one of the students has to record data in the lab. And sometimes there's one student that sort of sits back and doesn't do anything in a group of 3. This can't happen when they're doing this in 3 separate dorms, right? So everybody is fully responsible for the experiment, but they can learn from each other because they're on the same Zoom session. Not everybody has the best kind of starting materials. So for this experiment, I needed a water glass, and some people didn't have anything that was translucent, so they couldn't really read off the volume from the side, but they had to look into a mug. So there's experimental challenges that come up, but that's actually quite fun because that's sort of a higher level kind of learning where you say, well, I have to design my experiment differently now because I don't have the conditions that are in the lab. So I'm sure that there's a higher failure rate of labs, but because you have 3 students writing it up together, sometimes somebody has everything that they need, and so they do the experiment very closely to what I intended to, and then other people experiment a bit more, and that's fun too.
Great.
So when we do these experiments in the lab, I always have a follow-up where they can experiment a bit more. And this time, some of the follow-up happens on the first day because they say, well, I can't do that here. Like I don't have access to hot water or something like that. It doesn't work so well for, or I would say it works especially well for this course because it's a brief introductory rundown of all of chemistry. So there's some fun experiments about isolating gluten from flour. There's a lot of kitchen chemistry just by the very nature of it. Okay, any other comments or questions? Okay. Then I want to talk about this one aspect of turning figures that are commercial into figures that are available with an open license. And there's a little backstory to that. So I thought I would give a 45-minute talk at Open Ed where there would be some back and forth between the audience and myself. But they had so many applications that they said you could do a lightning talk, which is a canned video. So this one activity I wanted to do, I decided I can now do with you guys because you're actually here and real. And so let me just back up and show you that one picture again, or the slide collection. So I'll take the biochemistry as an example. So this used to be from the textbook and all the figures were copyrighted. And so I can't really make videos and post them on Vimeo or on YouTube, and I can't share it so much. So I went ahead and looked for open source figures for all of these. So these are now the open source version of it. And I just wanted to share some strategies. But before we do that, I want to ask you, do you have a favorite figure that is in the textbook and you can't really take it for an open educational resource kind of framework? It could be into a LibreTexts book or into a slide collection or into the video that you're showing. So what would be a figure that would be difficult for you to find?
You want us to describe a figure or to give you a URL for a figure, or how would you like this to
describe it, yes. So I guess you couldn't give me a URL because the figure you're thinking of might be commercial, right? And then so it shouldn't be on the internet. Okay, so I have orbital overlap with sigma and pi bonds. Cool. Ooh. I'm gonna wait a little bit more to see if we can get some other things.
I guess along the same line, you can talk about Huckel theory for an arbitrary, actually, let's say hexatriene.
Okay, I'll just write that down. Okay, while you're thinking about this, I wanted to have a figure that has a bunny acting out how a weak acid and base works. And sometimes you have to make it yourself. So here's my bunny. The ears are the lone pair. And then when it makes the bond to hydrogen, it puts on the hat. So I do that in class. I say, well, now I'm the acid, now I'm the base. I'm acting as an acid, I'm acting as a base. But the bunny was nice because it also shows that lone pair. And the other thing it shows is that at higher pH, you have less protons around, so you're more likely to be deprotonated. And then at lower pH, you have more protons around, and so it's more likely that bunny puts on the hat. So I probably wouldn't find this, so I had to make it myself. And it features our piano that we inherited when we bought a house, and they couldn't be bothered to take the piano out. Okay, I'm going to go with the first suggestion here, orbital overlap with sigma and pi bonds. And never do this in class, but I'm just going to put it in there and Google search it and see what happens. And so you can search for images. And there's some good stuff, but unfortunately it's from Chegg. So I wouldn't take a figure from Chegg because probably it was copyrighted and it was just copied anyway, not by them. So that's the question. How do you get figures that have the right kind of license? And I want to share with you a couple of strategies. And the first one I want to share with you, because this is LibreFest, is you can say, why don't you look on LibreTexts.org? So I will limit this search just to LibreTexts. And I would think because there's some organic chemistry texts on there, I might find something. Okay. And then David, you can tell me how close I'm getting to what you wanted. Is that good already? Or do you want to give me some extra kind of requirements that makes it? So did you want to specifically have a sigma orbital overlapping with the pi bond and a pi? So both a sigma and a pi orbital overlapping, is that what you wanted? And then we have to—
Let's introduce some phase into the orbitals while we're at it. If you want things to be complicated.
Right. Anyway, so this is one direct way. You just check if something on LibreText already has that figure. Sometimes you can just see in which chapter it is, and then you can search your way through it like that. There's also a way of searching on Creative Commons. Oops, that's too many M's. Oops, can't type. Sorry. So they have a special search engine. And I forgot what the URL is, so I'm hoping I can just find it like this. CC search, it's called up. And I found that it's especially good just for photos to find something. So we can see if we can still find orbital overlap. And you can filter this more by having the appropriate license. We would go with, I guess, CC by non-commercial for LibreTexts. And that's going to be a hard sell. But what I can do is look for bunnies, right? That will not be a problem if I need to find an open source bunny picture and then I want to modify that to put a hat on it. This would be a good source. And it's amazing how many pictures in the textbook are actually from, are not scientific illustrations, but they take from just real life to make the connection where you would find something. I don't know what the connection here is directly to organic chemistry, but you will probably find one. Okay. So those were two sources. And then for chemistry specifically, again, another one is to go to Wikimedia Commons. So often I find myself painstakingly drawing some molecule. And I guess Delmar gave me the prompt here to look for hexatriene. And so, and I guess structure, I should say. And I'm guessing I'm not successful here. Let me do something where we have better luck, maybe. Acetic acid, there should be something. I have to draw acetic acid a lot, right? And so I can quickly just go to Wikimedia Commons, and usually the common molecules are there. I think I will get the hexatriene as a homework and see if I can find it somewhere. It should be somewhere. And you'll have all versions, Lewis structure or skeletal or 3D kind of rendition. Okay, this was my quick show and tell. Again, are there any questions that you have about this topic, finding figures? And if you're interested in the other aspect of this, which is making figures, you're welcome to watch that 10-minute video for the Open Ed conference that I made. So this reiterates these concepts where you can find specifically open source, open license figures, but it also talks a little bit about making your own figures. So again, I want to open up for questions, comments.
We were toying with the idea of building an API or an application that would run a series of APIs through, Common Cartridge, Search, Unsplash, and all the other public domain or openly licensed repository of images. I'm getting the impression that you feel that that's a good idea to implement. So you can basically do a search and then it runs through all those searches and comes back and collates it and lets you go through them individually, like how you did it.
I guess the tricky part is with the licenses. If you have to have a second pass to check whether the licenses you think you're getting are really the licenses that there are.
Right. So if you go through the public domain ones, those are like Unsplash and Pexels and Pixabay.
Right.
Those are already put together. Creative Commons searches, I'm a little bit more concerned about because it's a different infrastructure, and I'd be very concerned with doing it through Google without really following up and making sure that those images are set up right, as I think you're expressing there.
Right. No, I think that would be good. I mean, the other thing would be just to have a little tutorial. I wouldn't mind sending off 3 searches, right? If I know the good sources for it. And I think some of that material is already, that tutorial material is already on LibreTexts, making some suggestions where I find stuff.
Yeah, we've collected a few, but we haven't. I wanted something like super powerful that provides everything that we can get.
The sense I get is that some sites have a higher ratio of hits for certain searches, and so you might be diluting it, right? I didn't get anything maybe on the Creative Commons in terms of scientific illustrations with all photos. But I guess you could structure your results like that so that you just give it in chunks rather than as a whole list that you have to go through.
Yeah.
So there would be ways of doing that.
Yeah. Let me Let me share something that I put into the link that complements what you did, which is this molecular generator.
Right.
If I can just have a minute, but I can't share. Oh, because
There you go.
So this taps into the PubChem, and you can then pull it, and then it makes the JS mol really quickly. So, for example, if you do caffeine, which I always misspell for some reason or another, it pulls it down, and then you can start to visualize it in different ways. That's if you want to make it dynamic, but you can just as easily use this as a mechanism to make a static image that you can pop in there, and to use. What did I come up with? Was it hexatriene?
Right, yes.
Okay, and there it pulls it from the database, although I don't like that. Although that's more protein oriented. I should stop doing that. I'm screwing up my hexatriene. And then now you have something to work off. It doesn't have all the orbitals or all the things that we would like to have for Huckel theory, but at least gives you a reference point to work off of. That is if your infrastructure that you presented doesn't really work out quite so well. So anyways, we discussed that earlier on today. I just wanted to make a connection between what you did and what we had done.
Mm-hmm.